Welcome back. In our previous videos, we covered GET requests and how to use query parameters for filtering and pagination. Today, we're diving into the POST HTTP verb, which is all about creating new resources in our Spring Boot application. Let's get started. Let's first understand what POST is. POST requests are used to send data to the server to create a new resource. Unlike GET, which retrieves data, POST is used for submitting data to be processed. When should you use POST? First, creating a resource. Use a POST request when you need to create a new resource on the server. For example, if you're adding a new user to a system, you would send the user details to the server via a POST request. Next, updating a resource. While put and patch are typically used for updates, POST can also be used to update resources, especially if the update results in the creation of a new resource. Finally, complex queries. POST is great for sending complex queries to the server that involve large amounts of data. For example, searching for records based on multiple criteria. Let's discuss the key characteristics of POST requests. Non-idempotent. POST requests are non-idempotent, meaning that making the same POST request multiple times can have different effects. For example, submitting a form multiple times could create multiple records. Request body. POST requests typically include a body that contains the data to be sent to the server. This data is often in the form of JSON, XML, or form data. Security. Since POST requests can change server state, they should be protected against cross-site request forgery attacks. It's common to use tokens to validate the authenticity of POST requests. Let's get started with practical implementation. So far, we've created GET APIs that fetch employee details from our database. But what if a new employee joins and we need to add their details? In this case, we need to create a new resource for the employee. This is where the POST HTTP method comes in. Ready to see how it works? Let's dive into creating a POST API. Today, we're going to learn how to add a new employee using our API. Our API will take employee details like name, age, and department in JSON format. Our service will then do a few things. Generate a unique employee ID. Set the joining date to the current date. Return the updated employee details in JSON format. Ready to dive in and see how this works? Let's get started. First, let's write the code in employee service to handle the creation of a new employee. After that, we'll look at how to expose this functionality as a POST API in our controller. Let's open the employee service class and add a method called addEmployee. This method will take an employee object as input and return an updated employee object as output. Now, let's override the addEmployee method in employee service impl to provide the actual implementation. This is where we'll generate the unique employee ID, set the joining date, and return the updated employee object. Now, we need to generate a unique employee ID. Since we're not using a database, we'll keep it simple. We'll create a variable to hold the current ID. Each time a new employee is added, we'll assign this ID to the employee and then increment the variable by 1 for the next request. Let's add a variable called sequence ID of type long. In the constructor, initialize sequence ID to 1. In the constructor, we previously hard-coded the employee IDs for the 5 employees we created in the last video. Let's update this by generating employee IDs using sequence ID and assigning them accordingly. Now, let's focus on our addEmployee method. Use sequence ID to assign a unique ID to the new employee. After assigning the ID, we'll increase sequence ID by 1 to prepare for the next employee. Next, let's set the joining date to the current date for the new employee. Now, let's save this new employee to our employee map. This way, when we need to fetch their details later, we can easily retrieve them from the map. Finally, let's return the updated employee object. This will include the unique employee ID and the current joining date we've set. So far in this method, we've done the following. First, we assigned a new employee ID using sequence ID, which already contains the next unique ID. Then, we increment sequence ID by 1 for the next employee. Next, we set the joining date to the current date. Finally, we saved the new employee to our employee map. Now, let's create our Post API in the employee controller. This API will handle creating a new employee resource. Ready? Let's set up the Post endpoint. How do we create a Post API in Spring? Spring makes it easy with the @post mapping annotation, which is specifically designed for handling post requests. We can also use @request mapping with the method attribute set to post. You might remember we used @request mapping when we discussed GetRequests. Using @post mapping keeps our code clean and focused on handling post requests. You can use either @post mapping or @request mapping with the method attribute set to post to handle post requests. Both work well, but for this tutorial, we'll use the more specific and straightforward @post mapping. To create a new employee, our API needs to receive the employee's data in the request. Clients will send this data, usually in JSON or XML format, depending on what our API supports. Spring provides a great feature for this, the consumes attribute in @post mapping. By using consumes, we can specify the format our API will accept, ensuring our application processes requests correctly. For our @employee API, we'll support only JSON. Add the consumes attribute to our @post mapping with the value application/JSON. Our API will return the updated employee details in JSON format. But how do we specify this in our code? If you remember from our previous videos, Spring provides the produces attribute for this exact purpose. By using the produces attribute, we can tell Spring to always return the response in JSON format. This ensures that our clients get a consistent and expected response format every time. So, let's add the produces attribute to our @post mapping with the value application/JSON. If you want to expose your API at a different URL, you can specify the path in the @post mapping annotation. But since we already have a global path defined as /employee in the employee controller, we can use the same URL for our @employee endpoint. Now, you might be wondering, how can the getEmployees API, which returns a list of employees, and the @employee API, which creates a new employee, use the same URL? How does Spring know which one to call? Here's the cool part about RESTful APIs. We can use the same URL for different operations because each operation uses a different HTTP verb. For example, get/employee fetches the list of employees. Post/employee creates a new employee. Even though they share the same URL, their combination with the HTTP verb makes each endpoint unique. This way, Spring can easily distinguish between the two operations. Remember, you can't have two GET APIs with the same URL because the combination of URL and HTTP verb must be unique. Now, let's get back to our API. We've set up the @post mapping annotation, but need to define the @employee method that will be triggered by this URL. This method will take an employee object as input and return the newly created employee as a response. Now, we want to take the employee object from the request body in our @employee method. But how do we let Spring know to convert the incoming JSON data into an employee object? Here's the magic. We use the @request body annotation. By adding @request body before our employee parameter, we tell Spring to treat the incoming data as the request body. Spring will then automatically extract the data and convert it into an employee object for us. Now, let's call the addEmployee method from employee service and assign the response to an employee variable. This will handle the business logic and return the newly created employee object. Now, let's return the response. Since we're creating a new resource, we need to use the right status code to let the client know it was successful. While 200 OK is used for general success, 201 created is perfect for indicating that a new resource has been created. We'll return the newly created employee object along with the 201 created status code to clearly signal that the employee was successfully added. Let's start the application. The server has started. Now, let's open Postman to test our new post endpoint. We need a JSON body with employee name, age, and department to test our new post endpoint. Instead of creating it manually, let's make it easy on ourselves. We'll call our getEmployee API with a specific employee ID, copy the response, and use that as our template. Now, let's create a new HTTP request in Postman. Select HTTP verb. Our API is of type POST, so select POST. Enter URL. Type localhost 8080/employee in the URL field. Click on the Body tab. You'll see different options here, but we need to select Raw. Once you select Raw, another drop-down will appear. Choose JSON. Paste the JSON body we copied earlier from the getEmployee API response. Make sure to remove employee ID and joining date from the JSON, since we don't need them for creating a new employee. For our request body, let's set employee name to Pankaj, age to 28, department to QA. Click on the Headers tab. Here, you'll see a content type key. This key tells the server the type of data the client is sending in the body of the request. You'll notice that Postman has already set this to application/JSON, so we don't need to change anything here. Now, everything is set. Let's click Send and create our new employee. Let's take a look at the response. You should see that employee ID 6 has been assigned, which means our new employee was successfully created. But we're not done yet. Let's put our work to the test. We'll use the getEmployee API to fetch the details of employee ID 6 and make sure everything was created correctly. Now, let's hit the getEmployee API with employee ID 6 and see what we get. Our response should show employee ID 6, name Pankaj, age 28, and department QA. This is exactly what we created, so seeing these details will confirm that our new employee was added successfully. Now, let's create another employee to double-check everything. This time, we'll use the employee name Ankit age 25, and department developer. Receive a response with the new employee ID 7. This means our new employee was successfully created with employee ID 7. Let's verify this by making another getEmployee API call with employee ID 7 and checking if it returns the correct details. Response should show employee ID 7, name Ankit, age 25, and department developer. This is exactly what we created, so seeing these details will confirm that our new employee was added successfully. Let's wrap up what we've achieved today. We mastered creating a new employee using the POST HTTP verb. We handled JSON data effortlessly and ensured our API returns the correct response format. We put our new API to the test by creating employees and verifying their details with the Get API. Thank you so much for joining us on this journey. In our next video, we'll dive into the put HTTP verb and learn how to update existing resources. Don't miss out. Hit that subscribe button and tap the notification bell to stay updated with our latest tutorials. See you next time.